Okay, so what's my outside function? Cosine. So what's the derivative of cosine? Negative sine. So it's negative sine, and the inside stays the same for this part. Okay. So then now we have to take the derivative of e to the 2x.
Which would be plus or minus or
Multiply. Because it's derivative of the whole thing times the derivative of the inside. Right, so it would just be e to the 2x. But now we also have to take the derivative of what?
Not cosine. You leave it. The outside times derivative inside.
But there's another inside. It's a 2x. Right?
Why?
Because there's multiple things happening inside. There can be lots of insides.
Outside, and the middle inside, and then
You start on the outside and work your way as far in.
Okay, got it.
I thought if they're just...
That was always what confused
Right.
me.
So if there's anything besides just x or a single variable in the e to the whatever, you have to go again and take the derivative of the exponent. Yes.
Okay, because I thought like with x squared.
No, yeah, it's not x squared. It's e to the 2x. Okay, so outside, inside, inside again.
So you don't have to, once you like inside again, you don't have to do anything with the cosine again?
No, it's gone. So then technically the way I would write this is negative 2 e to the 2x times sine of e to the 2x. That's how I would write it, just to make it neater.
Did you get -2?
The negative sign and then this 2.
Oh, you didn't put...
All right, let's do...
Was that the answer to that?
Okay.
Did you put a negative sign?
Yes.
When is this?
Monday.
Monday?
Oh.
Monday. Oh man.
Bye, guys.
Bye, Caitlin. Okay, so what can we do before we even take the derivative?
The ln, you can make it...
ln is 1 over x.
All right, that's the derivative before we take a derivative.
You take the 2 and move it over to the ln.
Yes,
And you
good
flip
job.
it
That was a
one.
derivative.
No, not for ln.
So it'd be 2ln.
So we're going to rewrite this as 2 ln.
Okay, I didn't know you could do that without it being the derivative.
You can that's how logarithms work. That's the power rule. Anytime there's an exponent with a log or ln, you can move it
If
in
there
front.
was like a 2x in front of instead of the ln, you couldn't do that.
Right.
Okay.
So now we can take the derivative.
Are you recording for Caitlin?
I am. I started recording at the beginning so Emma can have it too.
The derivative of the outside.
So is ln. Ln is our outer function.
Yeah.
Okay, so derivative of ln is what?
Is it derivative 2ln?
So it's 2, well, it's 2 times that. So over x. So x meaning the inside.
Oh.
It stays the same. It's 1 over whatever it's ln of, not just 1 over x. Like, the derivative of ln x is 1 over x.
Okay.
But if I have, like, ln of x to the 500th, it's 1 over x to the 500th, and then times x, the derivative of that derivative. Like, does that help?
Yeah.
Okay, so it's 2 over 3x minus pi e to the x. And then now we multiply that by the derivative of the inside. So the derivative of 3x is, derivative of pi e to the x is pi e to the x.
Oh, so pi stays with the e.
Yeah, because pi is just a coefficient here. It's not
Can
a,
you leave the minus though? You're
Yes.
not like multiplying pi times e to the x, so you have
Well, you are, but it's like if it's the same thing as if I had 2 e to the x, right? The 2 would just stay with it. So does the pi.
Could you technically just smush it all together? Like just makes it 6 minus pi e to the x.
Let that hand-
Oh, the 3 and the answer's 2.
No.
Could you just make it 6
Oh,
minus
thank you.
6 pi
Alright.
e to the
Why
x?
not? You smush?
Yep.
Oh, you just straight up smushed it.
I mean, you can on top if you want, but I would just
Oh, it's 3. Oh, I didn't
because the bottom has 3x and the top just has 3. If it was a 3x, yes, you could cancel, but otherwise,
Could you technically just carry that 2 over in the problem?
you could distribute
Make
it through.
6
Yeah,
minus 6
but
pi e.
don't do more work than you need to.
But I don't know if
That's
like
Ian.
if I do enough work.
That's the end?
Hmm?
Oh.
Usually, Isaac, for chain rule, you're not going to really be able to simplify further just by multiplying stuff in
Okay.
most of the time. Okay. Let's do another one.
What time is all game?
Can we try the one?
Mm-hmm.
You got theta symbol for all of them.
That's a 3. It's kind of ugly, but it's a 3. Too small.
What do we do with the theta? Just carry it on.
That's your variable instead of x.
Oh, okay, just treat it as an x symbol?
Mm-hmm.
Deal. Deal pickle.
It's like an x and it would just be 1.
Yeah,
like the 3 theta. What's the derivative of 3 theta?
3.
3?
So now let's do 3. Could you technically smush it all together
Mm-hmm.
into one big problem? Like,
Mm-hmm.
or is there steps to this problem?
I mean, you can kind of smush it.
How do you multiply the 3 theta into the other part of it? Do you have to do that? That's what your cosine. You're taking the cosine of it.
Mm-hmm.
Okay, so you.
I think I got it right.
I think I did.
What you got?
3
I got 3
cosine squared.
3
theta.
theta.
So it is.
Remember,
you have to
guys,
do, like,
sine
3.
squared means that it's sine squared. The squared is your outside function.
Okay.
Why is.
That's
Whoa.
how you write trig function squared.
Hold up. Why is it not cosine?
All right. I haven't taken the derivative yet, Isaac.
So you have to do that.
I'm rewriting that, yes, because you have to recognize that when a trig function is squared, the squared is your outside function. So then technically you're doing 2 sine 3 theta, then times your cosine 3 theta,
How do we
then times your 3.
Which will give you 6 sine 3 theta. Oh, then we have the cosine in there. That's scary, right?
Where'd you get your times?
Derivative of 3 theta.
Oh, where are the math class?
We're reviewing for a huge quiz on Monday.
Okay, you need to come to me as soon as you're done because I can't find Isaac's picture anymore.
I don't have Isaac's picture. They don't have that.
That's why I don't have Isaac's picture.
This is all I said, right?
I've got to have Isaac.
I don't have it. Oh my gosh.
All right, you guys want to do another one like that?
Absolutely.
Do I have another one like
chain
that?
was down here and
the implicit differentiation.
That's what we can do.
Let's do this one.
Hey! I don't know what it is. Oh, crap. You might know what the tangent is. The cotangent? Negative cotangent?
The secant squared.
The secant? You gotta take.
Oh wait, secant squared, yes.
Oh, no, I get it right. No, I didn't get it right.
We got this
Why do
tangent.
I not remember doing this? Secant squared. Is the x part, is the x squared another inside thing? Is ln x squared one thing or two things?
One.
It'd be one because it'd be one over.
Because technically, remember, you can move the 2 in front because it's ln.
Oh my god.
You can basically do that. Well, not really like that, but like, just remember that ln x squared is the same as 2 ln x. So like when you take your, yeah, so it would be 2 over x. So secant squared of ln x squared times 2 over x. That's the derivative of the ln x squared.
Yeah, I don't know how I'm gonna do it. I'm not know how I'm gonna do it.
So would your answer be?
Like stuff like that.
It would always
Little
be
things-
the exponent over
little
x.
things make me-
So would your answer be 2 over x secant squared?
So it would be, well, I would write it as 2 secant squared ln x squared over x.
Oh, wow. Could you do it the other way? Like 2 over secant
No,
x?
no, because that's all on top. Try that one.
Hey, what's that thing
Good
for
secant.
secant? Secant x times.
Wait, what?
What?
Secant times tangent.
Is secant?
Mm-hmm.
So it's secant. And then
Times
tangent?
tangent. Yep.
So secant of the inside, tangent of the inside.
Derivative of outside is
So like here, let's do this one together. So it's secant x minus 3x squared times tangent of x minus 3x squared. That's what it means by secant tangent. And then times the derivative of the inside part there.
Whoa, so you would have to times the derivative
6x?
by secant and tangent?
Not quite.
9.
The derivative is secant times. No, what? 9.
It's 6x.
No.
Negative 6x.
What's the derivative of x?
It's negative 6x.
1 minus 6x.
So you would have to put that with the secant and the tangent?
The inside, this goes with both, yes.
Oh, no. But
No,
that-
all right, no. No.
Or could
It's
you
just-
slap it on the end?
Slap it on the end. Yeah. Or beginning, whatever you want. I don't care.
Is the 1 minus 6x? Is that just how you wrote it?
That's the derivative of 1 minus 3x squared, yeah.
Do I have to pull 1 minus 6x through?
No. I wouldn't. That's a waste of time.
What is... Can you just put negative 6x secant and then all that?
No, because it's 1 minus 6x. You're not, like, this is one piece. Because derivative of x is 1 minus 6x. Like, this is one part. You can't just,
Your answer?
yeah. If you wanted to distribute this mess into one, yeah, I don't want to either. Dylan's asleep.
Hey, Ryan.
No, Dylan's.
Huh?
You asleep, man? Are you good? Do you need to go home? I don't believe you.
I'll take advance of the experience. I'm chill.
Okay. Are you going to be safe to drive home? Okay. Do you guys want to practice some of the implicit differentiation?
I still can't do these.
I can't do that.
I can't do it with all the sine stuff and cosine stuff. It's messing me up. And like when it's the multiple ones that you have to pull through, like the triple ones, I just cannot
Okay.
get them.
Let's go to IXL and look at some then. We can look at them together on the screen, okay?